Okay, good morning, afternoon, or evening, everyone. Welcome to the Demystifying the Cloud, Simple Workflows for Accessing NASA NSIDC DAAC Data in the Cloud, Earthdata webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Savings Time, so we're going to go ahead and get started here. What I like to do first is begin every webinar with just a few logistics. So to ensure the best audio experience, all participants have been placed in silent mode. But if you have any questions or you have any issues, please enter those into the Q&A panel rather than the chat, and you'll find that located on the right side of your screen. If you don't see it, click on the three dots and you should be able to add the Q&A panel to your screen. Okay, today's webinar is being recorded. The recording will be posted both to the NASA Earthdata website as well as to our NASA Earthdata YouTube channel within a week of completion. Once completed, I will send an email to all registrants with the recording links as well as a link to the presentation slide deck that's used within today's webinar. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and live demonstrations, and then we will allot a 15-minute Q&A period, which will follow. And depending upon the volume of questions that we receive, we may extend the Q&A session an additional 15 minutes from end time, but we will have a hard cutoff of 3:15 p.m. Eastern Time. During this afternoon's webinar, we will have two speakers. Our first speaker is Amy Steiker. She is a data engineer. Let me just pull up the agenda as well here. At the National Snow and Ice Data Center Distributed Active Archive Center, or NSIDC DAAC. She will begin today's webinar with an introduction to NSIDC DAAC data in NASA's Earthdata Cloud. From there, we will transition to our second speaker for this afternoon, Jenny Roebuck. Jenny is a data support specialist, also at NSIDC DAAC. Jenny will continue the webinar presentation with two live cloud computing data workflow demonstrations. She'll show you how to access ISAT2 data in the Earthdata Cloud by the first demo will be copying a file to your Amazon Web Services account. And then the second demo workflow will be via direct S3 access using earthaccess Python library. All right, once Jenny's demos are complete, what we'll do then is we'll toss it back over to Amy, who will close out today's event with some cloud computing and other help resources. From there, we will move to our final optional set of polling questions, and then we'll jump directly into the Q&A session. Just a quick note about the Q&A. We will try to answer all of the questions within the time allotted, but if we're not able to address your question during the Q&A or the extended Q&A session, our speakers will be able to follow up with you offline. With that, it is my pleasure to introduce today's first speaker, Amy Steiker. And so at this point, I'm going to stop sharing my screen and I will toss the presenter role over to Amy. So just give me 1 second here, if you would. Okay. All right, Amy, I'm going to toss that down to you. You should have it in just a moment.
Okay, great. Go ahead and share and jump right into the PowerPoint. Please just holler if you're seeing the presenter view instead of the main view, but hopefully we should be all set. So thanks again, Jennifer. All right, great. Thanks so much, Jennifer. So today, as Jennifer mentioned, Jenny Roebuck and I will be demystifying the cloud, and we're going to be demonstrating some simple workflows for accessing NSIDC DAAC data in the cloud. I also want to acknowledge our other co-authors, Luis Lopez and Andrew Barrett, who are a part of our DAAC team developing code-based learning resources related to data access and use, including some of the resources that we'll be sharing today. So I'll quickly walk through our agenda for today in a bit more detail than what Jennifer shared. So first, as far as our introduction, I'll provide a little bit of background on the NSIDC DAAC and our move to the NASA Earthdata Cloud. And then I'll also jump into a few kind of Earthdata Cloud getting started concepts as far as sort of what the cloud may mean for you. And then we'll jump into a few live demonstrations that Jenny will be covering. The first is we'll be looking at copying a file to your Amazon Web Services or AWS account. So we'll walk through this workflow from the NSIDC.org website as far as those mechanisms for discovering those available options, and then using the command line to copy files from the Earthdata cloud into your cloud environment. And then the second demonstration will kind of switch gears and focus on direct S3 access using earthaccess. And we'll talk much more about these terms and concepts in just a moment. So there we'll walk through the earthaccess Python library to easily search, access, and stream data in the cloud. And then finally, we'll wrap up with some additional resources and some upcoming opportunities. Before we get started, as part of the National Snow and Ice Data Center, or NSIDC, we first want to acknowledge the land and the people who call the cryosphere home. So NSIDC recognizes that the Arctic, subarctic, and mountainous regions around the world are traditional homelands of many Indigenous peoples. We offer gratitude and respect for Indigenous peoples' long-standing knowledge and stewardship of these lands and waters. NSIDC is committed to conducting research and managing data with respect for and in coordination with these Indigenous groups. So our cooperative efforts with partners aim to contribute towards preserving, protecting, and contributing to Indigenous knowledge for current and future generations. And you can head to our website, nsidc.org. You can search for in our featured research project pages for more information, as well as checking out the Exchange for Local Observations and Knowledge of the Arctic, or ALOCA website, which works and does a lot of direct work and research with Indigenous groups. So now I'll jump in and quickly introduce the NASA National Snow and Ice Data Center Distributed Active Archive Center, or NSIDC DAAC. So we are physically located in Boulder, Colorado, and we provide access to hundreds of data products in support of cryospheric research, as well as global change detection and water resource management. We are one of the 12 DAACs within NASA's Earth Observing System Data and Information System, or EOSDIS. And we're also the largest program within the NSIDC as part of the University of Colorado's Cooperative Institute for Research in Environmental Sciences, or CERES. So now that we've covered all of those acronyms, I'll also mention that we have over 800 data products and over 2 petabytes of data, and our archive continues to grow. So now I'm going to jump into some basics about this transition to the cloud to help simplify really like what the cloud means or may not mean for you. So today, all NSIDC DAAC data are still freely available to download from our local storage location. And this is also known as on-premises, or on-prem storage for short. So this method of downloading files to your local computer is still fully supported in cases where you may not simply need to work in the cloud. And I'll mention some of those considerations of sort of when to cloud in just a moment. But in general, if perhaps the amount of volume of data is relatively manageable, in terms of the time it takes to download, if you're able to perform computations without really pushing the limits of your computer's capabilities, this is a perfectly suitable approach. And again, we continue to support that today and into the future. But we have started to move many of our data sets to the Earthdata cloud. Just like our data on-prem, the data from the cloud can also still be downloaded for free using those same tools that you may already be familiar with. We'll also cover them in just a moment, such as Earthdata Search, or programmatically via something like curl or wget. But NSIDC DAAC now offers all ISAT2 and ISAT GLASS datasets in the cloud. And just for a real quick background on these missions, they're both altimetry-focused missions that describe elevations of sea ice, land ice, forest canopies, water height, urban areas, and more. And again, we'll do some demonstrations with ISAT2 in a moment so you can take a closer look at kind of what those data can look like when you access them in the cloud. Okay, but here's sort of where the real value of the Earthdata Cloud comes in. And this is where we start working with larger volumes of data where that time that it takes to download, may become burdensome and may even be prohibitive to you as far as, working with that data and doing your science. Additionally, such a large volume of data may push the limits, as I mentioned earlier, of your compute power that you may have locally on your own laptop. And you may also need or want to have a common compute environment for your team and research group, right, where everything is sort of configured in one place, where you can, it sort of helps to ease the ability to collaborate across groups and teams. So this notion of analysis in place, or this concept of bringing your compute or processing to the cloud, or excuse me, to the data in the cloud, provides several advantages over the more traditional download method. So in this case, you no longer, need to move data. You no longer need to move bytes from, the original archived location, and you will only need to pay for the compute needed to do your analysis. And I'll cover that in just a moment. So since we get a lot of questions, when it comes to those cloud computing costs, I do want to take a moment to clarify this a little bit. So as long as you're performing your processing in the same location as where the data are located in the Earthdata cloud, and again, I'll cover kind of some of those key terms in just a moment as far as what that means as far as Amazon location, then that cost is completely free to access. So that's denoted in that light blue kind of free price tag icon in the middle of that cloud diagram. And similarly, storage costs don't really apply in this example, since you're directly streaming the data from its native location. You're not actually moving it around. And again, we'll cover that example, kind of this concept of analysis in place, in just a moment when Jenny gets into her second demonstration today. Finally, I do want to cover compute cost. So that's denoted in that yellow price tag in the diagram. So I like to think of this as, just like your laptop costs money up front that provides you, with a certain CPU or certain memory. Those compute resources needed to run your analyses in the cloud, that does cost money. And we have a resource that we'll mention at the end that you can use to help you kind of estimate those costs. But again, I kind of think of it as the difference between like that upfront cost, like purchasing, a computer upfront to process the data locally versus something you can kind of pay for as you go, which can also be really beneficial. So there's several opportunities that we gain when we adopt this cloud kind of centric workflow. So I've already mentioned in the top left, that easy access to data. But just to emphasize, by working kind of alongside the data, you don't need to separately manage your own copies of the data that can get unwieldy with large data sets. But again, that option to download in cases where you're not inhibited by download or processing time, still freely available and 100% supported. On the top right then, as far as rapid analysis and scalability, so your processing software can essentially move to where the data are located. This really can improve speed, as well as the use of cloud services. You can leverage other services to scale that analysis. So large computation can also be kind of rented for short periods of time, as I mentioned. On the bottom left, reducing redundancy. So across the EOS, we now have this common infrastructure, common place where we can develop consistent tools and services across our DAAC data. Earthaccess is a great example of this, again, that we'll cover in more detail in a moment. And then finally, increased reproducibility. So by mitigating that movement or transfer of files, the cloud can enable a fully reproducible environment and fully reproducible workflow. And it's not only beneficial when it comes to publishing your results, but also when it comes to collaboration within a shared environment, as I mentioned earlier. So what does it actually look like to get set up in the cloud? Again, we get that question and provide a few kind of examples and resources of what this may look like depending on kind of the resources available and sort of what makes the most sense for your use case. So the first is do it yourself. You can create your own Amazon Web Services account. You can connect to a compute instance and sort of, off you go. The Earthdata Cloud Primer that's on the Earthdata, NASA Earthdata website, that includes more information on setup and also that cost management in particular, as I mentioned earlier. And Jenny will also kind of walk through this a little bit more in her first demonstration. That's sort of the method that we'll walk through once we're already set up. In the middle, we have this concept of a managed cloud service. And we'll actually use this in the second demonstration. So organizations like 2I2C provide cloud-hosted Jupyter hubs for research and education. And these environments can be curated depending on your software and libraries that you're familiar with and what will suit your needs as far as your data analyses. And really all you have to do is essentially, hit a URL, log in, and you're running Python in the cloud. And finally, there's institutional support. So smaller or larger scale options may exist for your research group or institution. This can vary. The example that I provided here is the NASA SMCE, or Science Managed Cloud Environment. That's one example, for NASA-funded researchers. There may also be NASA funding opportunities for cloud computing at your own institution as well. So once that environment's set up, your preferred language and environment are essentially connected to a remote compute instance, meaning that your compute is now running in the same place as the data, as I kind of depicted in that earlier diagram. So for NASA Earthdata Cloud, it is important to note that this is the Amazon Web Services, or AWS, US West 2 region. And Jenny will speak more to this in just a few moments. So these are just some examples. And again, you'll see both command line and Python in Jupyter Lab. Those two examples we'll show in just a moment. And the same could be true for instance, for our studio. All right, so as far as NSIDC DAAC's status on cloud migration, just to recap, all ISAT2 and ISAT GLASS datasets are currently available in the cloud as an additional kind of value-added option for those reasons I mentioned earlier. All data are available to download at no cost to you as a user of the data. They do still require a NASA Earthdata login account. Jenny will also point this out. She jumps into her demo. And then we also have an FAQ page that answers a lot of other questions that you may have. So please feel free to check that out and reference that. Of course, we can answer questions at the end of this webinar as well. And then on to future data migration plans. So over the next several years, all NSIDC DAAC data beyond ISAT and ISAT2 will be available in the Earthdata Cloud. We have this list below that provides our migration order. It includes these following missions that you'll see here, including SMAP, MODIS, VIIRS, etc. For snow and ice data sets, for MODIS and VIIRS in particular. And again, this lists other missions that our DAAC archives and distributes. You're welcome to check out our website, again, nsidc.org, for more information on these missions. And like I said, happy to answer questions as well about that status. All right, so I'm just going to give a little bit of a preamble to Jenny's demos, and then I'll hand it over to her. So there are two kind of key cloud access methods that we'll highlight today. The first is copying files to a cloud account. And this is a really great option if you're looking to kind of get started and understand what that looks like and sort of that AWS account sort of do-it-yourself setup utilizing the command line. This is good if you need one or a few files or kind of practice working in the cloud. You can utilize Earthdata Search and again a terminal or command prompt. And Jenny will walk through that. And then the second one, direct S3 access, good for working with large volumes of data. And you can use a Python library, earthaccess, that will explain in more detail to search and stream data files. And just for some definitions, because I know I did cover a couple of terms that may be new for you today, S3 is the Amazon Simple Storage Service. So data are located in S3 buckets, and you can think of these as being kind of analogous to file folders. They store objects that consist of data and their descriptive metadata. And then EC2 instance, I mentioned this in an earlier slide. This is the elastic cloud computing instance, and this can be thought of essentially as a virtual computer that you would set up and work with in the cloud. So with that, I'm going to go ahead and stop my screen share, and I will hand it back over to Jenny to start her demonstrations.
Thanks, Amy. I will share my screen. Okay. So yes, as Amy has already mentioned, I'm going to be demonstrating two workflows for working in the cloud. The first one is for copying a file from an S3 bucket to your EC2 instance. And this workflow is documented in a help article on our website, which I will show you how to get to. So from our homepage, if you go to the Data tab at the top, User Resources, and then Help Center. Then if you scroll down, you can filter by topic. So we have a cloud data topic, and if we click apply, and then you can see our cloud related help articles here. Currently we only have two, but we will have more in the future. The one we're going to be following today is the NASA Earthdata Cloud Data Access Guide. So if I click on read more, and here it is. Amy has covered a lot of this stuff already that's at the top. So I'm going to scroll down to the prerequisites needed to go through this workflow. So you need three things. The first thing is an AWS account, and you can find more details on how to set one up from this article that's linked from here. The second thing you need is an EC2 instance set up in your AWS account. And again, we link to an article from here on how to set one up. So that's like you're setting up your virtual computer in the cloud. One important thing to note is when you're setting up your EC2 instance, it must be in this US West 2 region in order to access the data. That's the region that all the NASA Earth data are in, and you need to be in the same region, essentially, like next to the data in order to access it. And that's an option when you set up your EC2 instance. And then the last thing you need, as with any NASA Earth data, you need a free Earthdata login account to access the data. And if you don't have one, then you can register for one from this link here. So I already have these three things set up in the interest of time. So we can start jumping into the workflow. So the first thing we want to do is we want to find the data that we want and the links, the S3 links to those data. And we can do this using Earthdata Search. So if I click on this link here, it should take us to Earthdata Search. And you can filter for any data sets that are available in the cloud by selecting this option on the left, available in Earthdata Cloud. And then in the search bar at the top here, I'm going to put ISAT2 because, as we mentioned, those data sets are all available in the cloud. And then the list should update to show all of the ISAT2 data sets in the cloud. And they are identified as such by this Earthdata Cloud badge. Now I'm going to use the land ice height data set as an example, which is also referred to as ATL06, which is like a shortened name for the data set. And you can find that in the data set description here. So if we click on this, it will show us the granules that are available. And it takes a few seconds to load. And like with any other data set that you're looking at in Earthdata Search, you can filter it using spatial and temporal filters. So I'm going to apply a bounding box by inputting some coordinates here. And I'm going to search for some tracks over the Juneau ice field in Alaska. Give me a second while I input these. Okay, and then you can see here the blue box with the bounding box, and then this list dynamically updates to show those tracks that are available over that area. I'm also going to apply a temporal filter. So I'm going to put a start date using this calendar of 1st of March 2020. And then an end date, again, 2020 will go to April, end of April. And again, this list here will dynamically update to show the granules that meet that search criteria. So we have 4 granules. So now we need to get those S3 links to these data. So if we go down to this download all button here and select that, that will not download the data. It's just going to take us to options in order to access the data. And then again, we're going to click on this green download data in the bottom left. And we should get a download status page. Just takes a few seconds to load. Okay, So here we have some HTTPS links, which if you want to download the data to your computer, you can do so by clicking on these links. We're not interested in that workflow today. We want to get these S3 links in order to work in the cloud. So if we go to this tab to the right, AWS S3 Access, and again, it will display some links, but these are S3 links. And they're essentially pathways to the data in the cloud. They tell us where the data are in the cloud. And that's one thing we need from this page. We need one other thing, and that is some temporary AWS S3 credentials. And you can think of this as like an extra layer of permission in order to access the data. And they're generated based on your Earthdata login credentials. So you can get these easily by clicking on this blue link here, and a new window will open. I'm not going to do that for security reasons because those credentials are linked to my own account, but I am going to go back to the help article to describe them in a bit more detail. But just to recap, from this page, you just need two things: the links, the S3 links, which tell us where the data are, and then the credentials, which give us the permission to access that data while we're in the cloud. So if I go back to the help article, so we've searched for the data in the cloud using Earthdata search, and we've got our S3 links. And these temporary credentials that we've also got from that page, just two things to mention. There are 3 credentials: an access key ID, a secret access key, and a session token. These only last for 1 hour. So if you go over that 1 hour time frame, you will need to generate some new credentials. And it's very easy to do. You just need to click on this link in this blue box and a new window will open. Enter your Earthdata username and password, and it will get those new credentials for you. So we have the links and the credentials. Now we can actually start by copy your data. So we can do this from either a terminal or a command prompt, which I already have open here. So I'm already logged into my EC2 instance. So now I need to set the environment variables. I need to set these credentials as environment variables. And we can do that using some simple commands, which we have in the help article here. So we'll copy this first command by clicking here. And then I will paste that into the terminal. And then we'll move this, your access key ID. And then this is where you would go back to that window with your credentials and paste that access key ID in. It is between quotation marks. You do not need to include those. You just want those letters, numbers, and symbols between them. And you need to paste those in here. So you would do that for the access key ID. And then you would repeat that for the access key and then the token using these 2 commands here. I've already done this, again, for security reasons, so you don't see my credentials. So the next thing and the final thing to do is actually copy the data that we want. So we can do this using one very simple command, which is here. And again, we can copy that from the article. And we can go back to our terminal or command prompt. And move this a second. And then I will put this in. And then now we need to get the link to the data that we want to copy. So go back, apologies for the back and forth. And we need to go to that download status page. And we can just copy one of these links by selecting this little copy button at the end of the link and clicking on that. And a green badge will appear to say it's successfully copied it. And just for future reference, you can also save all these links as a text file by clicking the save button, or you can copy all of them in one go using this copy button. But we'll just copy one file for now. And we'll paste that link in here, followed by a space and a period, which means copy it to here, and then enter. And there we go, that's it, it's copied the file. And I can show you that it's there. And there we go, there is one of the ATL06 files. So just a couple of things to finish on with this workflow. If I go back to the help article. So 2 things I want to note. Again, just to reiterate that your EC2 instance does need to be in the US West 2 region in order for this to work. If it's in a different region, it won't work. And then lastly, just a note that it does cost money to store data on your EC2 instance. So even if you stop it running, but it's still within your AWS account, the data will still be stored with that instance, and that costs money. So this workflow isn't really ideal if you're working with large volumes of data. The next workflow that I'm about to demonstrate is much more appropriate for this. Okay, so go back to the presentation briefly. Okay, so the next workflow I'm going to demonstrate is something called direct S3 access using earthaccess. So instead of copying the files, we're essentially going to be streaming them. We can think of it as like streaming a movie or a TV show. It's similar-ish to that. And we're going to do that using the earthaccess Python library. So a little bit about this library. It's an easy way to search, download, or stream NASA Earth science data with just a few lines of code. And the code will work the same whether you are working within the cloud or if you're outside of the cloud and just working locally on your laptop. So if you're just working locally, then you can use the same commands and it will just automatically download the data rather than streaming it. And it can be used in R using the reticulate package. And this screenshot here is just is basically what I'm going to be demonstrating in a couple moments, just to show the few lines of code that are needed in order to search for the data and then access it. So we'll jump into the workflow. And this, again, is documented on our website. And it's in a notebook tutorial in our GitHub repository, and you can access it from data, user resources, and data tools. And if we scroll down and select interactive tutorial filter on the left here, and then the notebook we're going to be following is this ISAT2 Cloud Access notebook tutorial. So if I click on that, and here it is. Just a note, I'm going to be presenting a much more streamlined version of this tutorial, just to highlight how quick and easy it can be to search and access data using earthaccess. But for future reference, this notebook obviously contains a lot more detail and references, so it's a great resource to come back to after this webinar. Okay, so moving on to actually demonstrating earthaccess, I have one more caveat before I start. I am running this in a managed cloud environment, which is one of the options that Amy mentioned earlier. Do not worry if you do not have access to something like this. You can still use earthaccess and run the notebook in your own EC2 instance. It just requires you to set up your own Jupyter lab. And we have a tutorial on how to do this coming very soon. Okay, so without further ado, I'll actually jump into demonstrating it. So the first thing we need to do is we need to import the libraries that we want to use. So we're going to import earthaccess, which we'll use to search for the data and stream it. Then once we've streamed the data, we're going to load it into a data set using Xarray, and so that then we can find one of the variables within those granules and plot it using HVplot, which is an interactive plotting tool. So that's it, just 3 packages or libraries. So I'll just load those. Okay, the second step is we need to authenticate. We need to provide our Earthdata login credentials. So I'm going to save this in the auth variable. And I'm going to use the earthaccess login method, and that's it, just one command. In terms of how you provide your username and password, you have 3 options. One is you can set them as environment variables. The second is you can have them already saved in a netrc file, which is like a text file which contains your username and password. And there are directions on how to do that linked from the notebook tutorial in the GitHub repo. Lastly, if you don't have either of those, then it will automatically prompt you to enter your username and password. I have a netrc file already set up, so we'll use that. So if I execute this, it tells me what it's doing. The main thing to pay attention to is that it tells you you're now authenticated. And one great thing about earthaccess is that it handles those temporary S3 credentials for you. So it's none of that copying and pasting and generating them. It does all of that behind the scenes. So it really simplifies that process. So now the next step, we can actually search for data like we did in Earthdata search. So I'm going to save this in the results variable. And I'm going to use the earthaccess search _ data method. And again, it's one line of code, but I'm going to separate it out here so it's easier to see. And we just need to provide some search parameters. So the first one is the dataset name. So we'll provide the short name, like the shortened version of the dataset name. And you can find this for any dataset on the dataset landing page. So, for example, for this land ice height dataset, it's underneath the title after dataset ID. That's another way we refer to it, but this is also the short name, ATL06. And you can also find the version number of the dataset in the title, which is what we'll need in a second. So I will set the short name as ATL06. And then I will give the version number, which is usually 3 digits. So I'll put 006. And the ISAT2 data are available both in the cloud and on premises. They're exact copies of each other, just different locations. They're archived in different locations. So we just want the ones that are in the cloud. So I'm going to set the cloud hosted parameter to true. And now we can provide some of those spatial and temporal filters. So I'm going to specify a bounding box, again looking for tracks over the Juneau icefield in Alaska. So I'm going to enter these in the order of west, south, east and north. Okay, and then we can also provide a temporal filter with a temporal parameter, and you provide a start date in the format year, and then month. Oh, sorry, I actually put the month, and then day. So we'll do the 1st of March. And then give an end date, again in the same format. So we'll go the end of April 2020. And that is it. Those are our search parameters. So if I execute this command, and it will tell us how many granules meet this search criteria. Not a big surprise, it's 4 because we've used the same parameters as we did in Earthdata search. So now there's only really one thing left to do, which is actually stream the data. So I'm going to save this in the granules variable, and I'm going to use the earthaccess open method, and I'm going to provide those search results that we just got. And that's it, just one line of code. So if I execute this command, and it will tell me what it's doing. It tells me how many granules, the size, the total size of the order, and then the progress of the request. And there we have it. We've streamed that data. We've not physically copied it. Again, it's a bit like streaming a movie or a TV show. So here now we can just use the data however we normally would. So if you have an existing Python workflow for analyzing or processing the data, this is where you could start to use that. I'm just going to provide a quick short example of loading the data and plotting one of the variables. So I will save this in the DS variable and use xarray to load one of the granules into a data set. So one of those granules, and then these are HDF5 format. So within that, the data are grouped. So I need to specify which group. So I'm going to look at the ground track 1, the left beam, and then select the land ice segments group. And then within that, we can select one of those variables. So I'm going to select the land ice height variable, which is h_li. And then we're going to plot it in a scatter plot using HV plot. No, that needs to be between quotation marks. And I'll set the size to the dots of 2, and that's it. So if we execute this, it will take several seconds because it has to find the file, find the group, find the variable, and then plot it. And these are relatively large files, so it does take a little bit of time. But a plot should hopefully appear here in a second. Whilst that's trying to load, oh, there we go. So here we have a plot of land ice height from Grand Track 1, the left beam, over the Juneau ice field in Alaska. And that's it. It's as simple as that. So just a few things I want to kind of note before I hand back to Amy. Obviously, you can stream much larger volumes of data using this method. It obviously just takes longer and we don't have that much time today. But how long it takes also depends on the size of each granule and also its format. So for example, if you're streaming a cloud optimized format, such as cloud optimized GeoTIFF, is amazingly fast. It's amazingly fast how it streams. So yeah, that's just something to be aware of. Secondly, you can use the same earthaccess commands to download the data if you're working outside of the cloud. So for example, scrolling back up, if you executed this open command, instead of streaming it, it would automatically download it, but you don't need to change what you're typing in. And then lastly, earthaccess can be used to access most other NASA Earth Science data at other DAACs. It's not restricted to NSIDC DAAC. And it really is a great library because it simplifies everything. It does a lot of the nitty-gritty behind the scenes, so you don't have to worry about it. And you can just easily search for the data, stream it, and then you are able to focus on actually using the data for what you want. So yeah, so a big shout out to Luis Lopez at NSIDC who developed this library. And now I think we're going to finish with a summary. So I will hand back to Amy.
Okay, great. Thank you so much, Jenny. That was fantastic. So yeah, just going to wrap up with a few summary slides just to recap a couple of the concepts that we talked about today. So Earthdata Cloud is something for you to optionally take advantage of, right? So it can enable more efficient science, particularly with large data volumes. I think that's a really key thing to keep in mind. You certainly don't have to adopt this workflow if you're not constrained, as we mentioned earlier, by data volume size, download speed, your computer's resources. That's perfectly fine. We still support that ability to download data to your local computer for free. Recap on our status. Currently, ISAT Glass and ISAT 2 data are available in the cloud, and all NSIDC DAAC data will be in the Earthdata Cloud in the coming years. And then just to summarize Jenny's excellent demonstrations today as far as getting started in the cloud. So one method you could do is to kind of play around utilizing some of those command line codes to copy data from the S3 bucket to your own cloud account. That does cost to store that data in your own account. So that other option that Jenny just presented, if you're working with larger volumes of data, the direct S3 is a great option. So instead of saving those native files into your own space, you're just accessing and really only using the parts of it that you need. And that can, again, improve sort of performance and processing speed. And then you can save those processed results. Next slide, Jenny. All right, and then just want to end on several resources. So I think Jennifer will add several links now into the chat for you to reference, starting with NSIDC resources. So we have quite a lot of information in an Earthdata Cloud space on the NSIDC.org website. That includes that FAQ page that I mentioned earlier, the Cloud Data Access Guide that Jenny walked through in the first demo, and a list of available data sets in the cloud. And that will get updated as we grow the number of data sets in the cloud. The dataset landing pages as well, Jenny showed that briefly, does include links to all the available tools and services that we have, including NASA Earthdata Cloud for cloud-enabled data. So there's a link to that landing page of ATL06, the land ice height ISAT2 dataset that Jenny demonstrated. And then any questions, you are welcome. We encourage you to contact our NSIDC User Services office. Our email is nsidc@nsidc.org. We also have a support button on the bottom of every web page that'll get you to our USO office as well. All right, another thing I want to mention, so NASA OpenScapes, this is a mentor team across NASA DAACs. So several of us at NSIDC DAAC are a part of this wonderful community. We are co-creating and teaching common tutorials alongside researchers as they migrate their analytical workflows to the cloud. So the Earthdata Cloud Cookbook, I think Jennifer had linked it earlier as well, that has several tutorials and how-to guides, including the use of earthaccess, also with R and other command line how-to examples for working with not just NSIDC DAAC data, but other data in the cloud. And you can check out more info at that URL as well. And then finally, for my last slide here, other NASA Earthdata resources and also upcoming opportunities that we wanted to bring awareness to. So as far as the NASA Earthdata website, there's a space on the Earthdata Cloud Evolution. You could find more info more broadly as far as that general kind of status and information on the NASA Earthdata Cloud. And then we also have a NASA Earthdata forum. We highly encourage you to check that community out. There are many questions that are posted there and discussion within the community, in particular on the cloud and many other topics. We also support that as well and check it out and help to answer questions there as well. And then last but not least, AGU 2023 fall meeting. For those of you who are planning to attend that this upcoming December, there are a couple of learning workshops that we will be supporting. And registration info is coming soon. These aren't available yet, but keep checking back on the AGU website. The first is enabling analysis in the cloud using NASA Earth Science data. So that NASA OpenScapes group that I mentioned earlier, we will be supporting that. So that'll be a broader kind of learning workshop for NASA Earthdata Cloud across the DAACs. And then finally, cloud computing and open source science software for cryosphere communities. That's another one that we will be helping to support, and there'll be a lot of great learning opportunities there, particularly for cryospheric applications. And I believe that is all we have. So I'm going to hand it back over to Jennifer, and we'll move into our final polling questions and Q&A. Thank you.
Okay, great. So thanks so much. What I'm going to try to do here is share the lobby polling results with the attendees. I don't know if that gets emailed. Perhaps it does, but it will not include individual results. Okay, and then we're going to open the final end polls. And these will stay open too, right, even past the time that the event has ended. So I can, people have an opportunity to weigh in for like 30 minutes or so. All right, so let's go ahead and tackle. There were a couple of questions that were asked in the chat, and then I will move directly to the Q&A questions. Okay, so I want to make sure that I am going to not miss these. Okay, if you could just bear with me for a moment here. And I'll jump back up. Okay, so one of the questions is, what is the maximum number of files or granules that I can handle in the cloud? For example, could you take all of the archives or historical granules from 2013 to 2023?
Yeah, I'll jump in. That's a great question. And I think in some cases, I'm not sure if you're talking specifically to, let's say, processing or analyzing those files. So maybe depends on what you're sort of doing. But what's really great and beneficial about the cloud, as I mentioned, is that you can kind of scale your processing and compute resources to handle that load. And then as far as sort of that access or streaming data, again, there really are no limits there. It's really just a matter of ensuring that you sort of have the compute set up to handle that sort of data volume. But there's certainly no limits as far as accessing files, and that's again something we are, a big reason we are moving to the cloud is to help facilitate that ability to access large volumes of data. So certainly no restrictions.
Okay, well, thanks so much, Amy. And so the next question within the chat, and then again, I will transition to the Q&A panel, is, pardon me, but which cloud services are going to be used for storing NSIDC DAAC data? AWS, GCP, Azure?
Yeah, I will jump into that. So all NASA Earthdata, all the data archives across EOSDIS, we are all moving into Amazon Web Services. And in particular, the data are located, there's several different regions where those data are hosted in AWS. All NASA Earth data, including NSIDC DAAC data, are going to be, you're currently and also will be, as we're migrating data into the US West 2 region specifically for AWS.
Excellent. Thanks so much, Amy. So now we are hopping into the Q&A, but of course I'll check the chat a little bit later as well. And just a reminder to everybody, if you have a question, please enter those questions into the Q&A. If you don't see that panel, you should have 3 dots in the bottom right corner of your screen. And if you click on those, that will provide you with panel options. And then you can insert a check mark next to it. So the next question is direct access to S3 for data downloading free?
Yes. So to sort of clarify a little bit, all data download is free. Absolutely, that continues to be freely available. So if you are, were to go to, let's say, Earthdata search, find the files that you need, you can get a HTTPS link, click on that and download. That is all freely available. Similarly, if you are working in the cloud next to the data, again in that AWS US West 2 region, you can stream and access, like Jenny also just showed, as far as copying files, that is also free, but you have to be in the US West 2 region in the cloud in order to do that.
Okay, thank you. Thank you, Amy. Give me just 1 second here. I'm going to up onto the next one. What is the price for setting up an AWS account?
Yeah, also I'll go off and on video as well. Yeah, so as far as the cost, there is a free tier option available for AWS. So again, that Cloud Primer resource that we shared provides some examples of how to set that up. So that free tier is available, and so it can be free. Again, though, depending on the sort of compute requirements that you need, if you're handling large volumes of data, and you need to kind of scale up the compute, I think that free tier has a fairly limited, processing power. Then you're kind of looking at a different pricing structure, but it is completely free to set up initially.
Yeah, and I'll just add to that. I was using an instance that was in the free tier when I was in the first workflow. So when I was copying those files across, that was all within an instance that's available within that free tier.
Okay, thank you. And so there's a follow-up question directly related to what you were just discussing. So to confirm, using AWS S3 CP from any server not in US West 2 is not free.
Yeah, it's sort of not an available option today. So, if you're not working within that region, the sort of alternative option is to download. Jenny, I know you went off mute too, if you have additional information there. So yeah, today, like that cross-region access is not available.
Yeah, I was just going to say, I don't think it's an option, so it just won't work. So yeah, it's just best to stick in the US West 2 region.
Well, thanks so much, Jenny, and also Amy. So there are a couple of more questions in the chat. I'm going to go ahead and take care of those, but if everyone could please enter their questions into the Q&A panel, that would be wonderful. Okay, so the next question is, okay, so this is more of a comment. I was able to write a Python computer program using NASA weather data to predict soil moisture for 30 days in the future for agriculture land in all parts of the world. I don't know how to introduce my plan. I don't know if you have any tips or suggestions in terms of how one might go about doing that.
Sorry, I was going to say, do you mean you're not sure how to transfer it to the cloud? Is that the question? Unless Amy understands it more. I think we need a bit more clarification, maybe.
Yes, so if this user could enter some clarifying points into the chat or into the Q&A, that would be wonderful. And then we'll get back to this in just a moment. Okay, so the next question is, and also from the chat, I'm not an expert in AWS. Can we have access to the data without downloading to develop a software in AWS, for example, a machine learning project? If that is possible, could you please give a brief description?
I'll generally say that yes, absolutely, taking advantage of the cloud for cases like machine learning applications, like that's a huge benefit. So like in general, yes, that's absolutely an option. And I would say if you have more kind of detailed questions on particularly like the sort of data access or sort of how to utilize that cloud-based direct access within, maybe an existing workflow, we're happy to help you further. You're welcome to, I was going to mention this in the last question as well, like please don't hesitate to contact our email, nsidc@nsidc.org as well, for more, if you kind of want to work with us in more detailed kind of workflow or use case questions. I know that's a really vague answer. I don't know if anyone else has wants to jump in the panelists.
Well, thanks so much, Amy. So the next question is, what's the advantage of using S3 protocol rather than HTTPS for downloading a copy of the data?
Well, I can take this if you want. So S3, you have to be in the cloud to use S3. So it's not really a benefit, it's just more of that's the method that's used. HTTPS is that's the benefit if you're working outside of the cloud. Like if you want to download the data, then HTTPS is what you want to use. But S3 is just specific to the cloud, either copying whilst you're working within the cloud in that EC2 instance, or streaming it when you're working within that EC2 instance. Hopefully that answers your question. It just depends what you're doing and what environment you're working in, I think is yeah. But please, anyone else jump in if they have additional things to add.
Well, thank you, Jenny. So the next question is, let's see, GitHub code spaces lets me choose US West as a region. Will that work?
Yeah, so as long as it's US West 2, there I believe is also a US West 1 region. So without kind of seeing it exactly, seeing an example, I'm not sure if that is an option for you to specify in more detail, but as long as it's US West 2, then yes.
Okay, thank you very much. I was looking to see if there was additional follow-up here from the previous question. Okay, so let's continue forward here. So the next question is, how is earthaccess different than querying the, so like the CMR stack, NSIDC, ESC, wait a second, a little bit tongue-tied, ECS endpoint using stack tools like PyStack client follow-ons? Does earthaccess support other DAACs? There's actually kind of multiple parts to this. So the first bit is, How is Earth Access different than the CMR and the STAC ECS endpoint using tools like PyStack Client? The second bit is, does Earth Access support other DAACs? And the final piece is, are the data always in native format, for example, HDF5, or more analysis friendly like cloud optimized GeoTIFFs? So I'm happy to repeat those three pieces if you like, but the first part again is, how is Earth Access different?
Yep, I can. I think I got them. I got them all in my head. I saw the question, multiple questions earlier, which are great. Starting, I believe there was another question on Stack, I think, as well. So as far as the Earthdata, Earth Access and Stack, currently Earth Access utilizes the Common Metadata Repository, or CMR, that API on the back end. It does not yet directly interact with Stack or CMR Stack, but I will note that all NASA EOS DIS data, including NSIDC DAAC data, including on-prem and in the cloud, support the CMR Stack endpoint. So that is available kind of separately. However, we certainly acknowledge that, and there's a lot of interest in utilizing and integrating that Stack endpoint into Earth Access. So it's actually something that's been discussed on our GitHub repository. We definitely encourage contributions and ideas there. So it is something we are considering on our roadmap. The second, I remember the last question on different formats. Or no, Earth Access being supported for all for other data.
Yes, that's right.
Yeah. Yes. So the answer is yes. It's not just an NSIDC DAAC supported tool. It again, because it utilizes the Common Metadata Repository, which supports all NASA EOS DIS data, you can utilize it for all NASA Earth data. And then finally, as far as file formats, yes, currently it will you will access the sort of native format as it is archived at the DAAC. So for the ISAT2 example, that's HDF5. Other data sets we may archive in NetCDF or GeoTIFF. There's another service, NSIDC DAAC doesn't yet support this, but other DAACs do. We do have reformatting services available through NASA Earth Data for data sets in the cloud called Harmony. So that is an option for some data sets across other DAACs where you can do that reformatting, let's say to cloud optimized GeoTIFF, or other formats, but not supported for NSIDC DAAC data in the cloud yet.
Okay, perfect. And then I'm not reading the questions that were answered with a response that's been typed into the Q&A. We have entered the extended Q&A period, so we have 15 minutes remaining. Is it possible to run this example without an AWS account, an EC2 instance?
No, is the short answer. You need, for both those workflows I just showed, you need an AWS account and an EC2 instance and an Earthdata login. Those are the things that you need to work with in the cloud. But just to reiterate, even if the data are in the cloud, you still can download them to your local computer for free using the HTTPS links. Hopefully that answers your question.
Well, thank you, Jenny. And I'm just realizing that Andy from NSIDC DAAC had already typed in a response, so forgive me for the redundancy here. Okay, so let's move on to the next question. Is there any data for snow height as well?
Good question. I don't think so. We can get back to you on that. We can follow up with you on that just to confirm, unless Amy knows off the top of her head.
As far as ISAT2 data, so ISAT2 does measure, has global coverage. Depending on your interest in particularly like freeboard, so kind of that height, including snow and ice above the sea surface. There are ISAT2 products that provide that height, but as well, again, it has global coverage. So even for some of the land products, you can get those returns. I couldn't give you again more details on that, but you're welcome to check out our website and look at other again, if you're interested in ISAT2 data in particular, what those available options are. But freeboard in particular, yes, that is a parameter that's in one of a couple of our data sets.
Okay, well, thanks so much, Amy. Just skipping up here to make sure I haven't missed something in the... Okay, so the next question is, does the plot end? So this was when you were conducting a demo, Jenny, and I don't recall specifically at what point, but the question is, does the plot represent the bounding box or the granule?
It represents the granule. So that, yeah, when we applied that spatial filter, that was just to find the granules that went over that area, but it wasn't subsetting the data. So it's for the granule itself, not the bounding box.
Okay, thanks so much, Jenny. And just for a confirmation here, okay, so there's a question in the chat. I'm going to skip back up there real quick. So let's see. What is the update rate of ICE data available? Meaning, how often will we be able to access measurements for a given coordinate box?
Yeah, for ISAT2 data, it's on a 90-day repeat cycle. So particularly like for cryospheric measurements, but yeah, it's that 90-day repeat. So every 90 days, it's going to kind of hit that same location.
Well, thank you very much, Amy. So the next question, it's really more of a confirmation. So if you could, so differences between downloaded data to your EC2 instance, which costs the user money, versus streaming data during processing is speed. Streaming is free, but may be slow. Download to EC2 is faster, but incurs a cost to user. I think I've got it. So can you confirm that that assessment is accurate?
I think it would depend on the data. So the reason it may have seemed faster between those two workflows is I was only downloading one file or one granule, but in the second workflow, I was actually streaming 4. So that's why it might have seemed slower, but that's because there was more data. So streaming, like I said, can be fast. It just depends on the size of the granule and the format. So when you have cloud optimized formats, it is really fast. So yeah, hopefully that helps a little bit. I think it just depends on what data you're using. It is a bit case dependent. But you're right about it does incur a cost to the user when you're downloading and saving it within your cloud environment. And the streaming, is free. But any results that you save from processing that data within the cloud, you'd obviously, if you stored that would cost as well. I don't know if Amy has anything to add to that.
This is Andy Barrett. I was just going to clarify. You're not, the download is free. It's the storage that you have to pay for. And so you're not being charged for interacting with S3 or HTTPS. But you would, if you want to keep that file within some storage system on AWS, then you would have to pay for it.
Well, thank you so much, Andy, for that additional input, and for Jenny and to Amy. And we're going to transition to the next question here. Is there any plan for associating this data among other NASA DAAC data in STAC?
Yeah, so again, there is so the Common Metadata Repository, which again, supports all NASA EOSDIS data, has a STAC endpoint. So that is available for, again, for all NSIDC DAAC and other DAAC data. I didn't know if you have a follow-up question there, let us know. And also the Earthdata cookbook that we provided a link to does have a couple of examples for how to work with those STAC endpoints, particularly for LPDAC, HLS, Harmonized Landsat, Sentinel data sets. There's a couple tutorials there on that.
Okay, thank you. All right, so the next question here. So I don't know if this has already been covered. And the question is STAAC available as a resource for indexing the available data sources? I guess you've kind of spoken to that a bit here already.
Yeah, I don't have much to
Okay.
add. Yeah.
Okay, so the next question is, let's see, about, okay. So the next question actually has to do with VIIRS data. My question is a bit of the red line about VIIRS data. Is somewhere data in 375 meter nominal resolution available? You can speak to the NSIDC products. There are 375 meter VIIRS data products available. Certainly at other DAACs, but I will defer to Amy or Jenny if you would like to provide additional input here, and I can follow up with this user offline.
Yes, we do have some 375 meter resolution data. To see a list of it, it's probably easiest to go to our website and look for the VIIRS data there. NSIDC.org/data/VIIRS, and you'll be able to see a list of those data sets that are available. But yeah, we do have some. Snow cover and sea ice cover. Yes, yeah, we have quite a few. So.
Okay, perfect. Thank you. Okay, so the next question is, so Amy, I think, mentioned that NASA cloud data is moving toward AWS exclusively. Will various NASA data sets currently in the Azure Planetary Computer Data Catalog or Google Earth Engine Data Catalog stop being updated moving forward?
So those, yeah, like the data sets that exist that you are that you're able to find in those locations, Google Earth Engine and Azure, those are sort of, I would say, not necessarily synced or tied to the the Earthdata cloud migration. So the short answer is no, there's not like a direct, once they move into Amazon Web Services, that those would go away. Those are not the sort of official archived location for the data, however. So the ones that have sort of been copied over to there are sort of copied from those DAAC locations. But again, I don't believe that the sort of migration status necessarily directly is impacting that availability.
Okay, thank you. The next question is a follow-up question. A follow-up question for Amy is the AFAQ, or I don't know if this is the correct way to pronounce this acronym, AFAIK, data transfer and AWS S3 cost. Just wonder if it's the user's account pays for this data transfer cost.
Yeah, and I think so. Yeah, as far as I know, the data transfer. I think Andy and Jenny maybe covered this a little bit. Just to clarify again, like the download does not cost money. Streaming data, as long as you're in US West 2, does not cost money. If you were to, as Jenny mentioned in her first demo, copy. If you're copying files kind of in your own EC2 instance, or decide to, again, copy data into a separate storage location, then you would incur a cost on that storage, but that's not required, and that's why again, we sort of promote the sort of direct accessibility, that is entirely free. So.
Okay, thank you, Amy. So the next question is, how can the AWS command line interface be used to directly access and download the Earthdata resources?
That's a good question. I think it can be, but it's not something we've looked into yet. But I think it can be used, right, Amy? Yeah, it's just not something we've produced a tutorial for yet.
Right.
So, but it is something we are aware of. So yeah, if that's something users are interested in, then yeah, we can definitely provide, work on resources for that.
Okay, thank you. The next question is, let's see, what is the temporal domain of these data? Are all of the data available for the same time periods?
If you're talking about ISAT2, yeah, I don't know off the top of my head the temporal domain, the temporal period, but they all cover the same period. Yeah, if you're talking about ISAT2 data. Yeah, let me look up hang on. I'll find one and then I'll be able to answer that question properly, unless Amy knows it off the top of her head.
Yeah, I mean, if the question is sort of about the data set coverage across the ISAT2 mission, then right, like, you know, the mission started collecting data, like launched in 2018, I believe started collecting, you know, a few months after that. But that coverage, I believe, you know, there might be slight changes, but it should all be the same across all the products. But I don't know, again, if the question's across different missions or not. So please, yeah, if you want to clarify what data you're referring to, we could give a more concrete answer.
So I'm just checking to see if there are any additional questions. We have about a minute left. Thank you to Alex in the chat for providing some additional resources and information about data transfer or just some general AWS helpful points. Let me just scroll through the chat a bit. I don't think I've. And so one question that I can answer. Okay, here's the final question. All right, what is the typical spatial resolution of ice data measurements, degrees, latitude, longitude?
And depends on which instrument you're referring to. If we're talking about ISAT2, I don't know, Andy, if you're if you happen to know off the top of your head. You are a sea ice expert, and also I don't know if they're referring to sea ice or not.
Oh, sorry, Dandy, go ahead.
No, go ahead, Jenny.
I was just going to say, for example, the ISAT2, the ATL06 data set that I demonstrated, that has a spatial resolution of 20 meters. So, but yeah, Andy, please expand on that.
Yeah, it depends. I guess there are several resolutions. It certainly depends on product. The spacing between the individual geolocated photon returns is in a long track is, I think, 70 centimeters. So, but that gets aggregated as you go into the higher level products. But you have each ISAT track is split into 6 beams that may comprise 3 beam pairs. And I'm blanking on the exact widths between them. But those are several kilometers apart. So it really does depend on whether you're looking at a single beam, a long track, or whether you're looking at the distance between beams. But all that information is in the product pages on our website.
Yes, and I did also include that as a response in the Q&A. Okay, with that, we have run out of time for the Q&A session. I appreciate what we'll do now is we'll leave the virtual meeting space open an additional 10 minutes. If you think of something, but we will log off from the audio component. I would like to thank our Q&A panelists. So thanks to Kate Heitley, and also thank you to Andy Barrett for joining, and also to our speakers, Amy and Jenny, and my backup hosts. And then most importantly, thanks to all of you for taking time out of your day to join us this afternoon. We really appreciate it. And I hope to have this recording added to the NASA Earthdata webinars and tutorials page under the Learn section within the next few days, and also added to our NASA Earthdata YouTube channel, where you can find there are probably 340 or so videos, some very specialized, and many data recipes, and quite a few cloud computing based data discovery and data access webinars. So thanks so much, everybody. With that, I will forward the Q&A log and the chat log to our speakers so that they can follow up with you offline. We're going to log off from the audio component and leave the virtual meeting space opened. All right, take care, everybody. Goodbye now.